Yes. What about now? Hello, am I audible? Okay. Perfect. So what I can do is that, let me share my screen once again. Okay. Okay then. So let's get started now. So can anyone tell me what we have covered up in our last class? What things we have covered up in our last class? Who will give me just a brief overview of our last week's class? Okay, there are two Shubham. So let's start with the Shubham Kumar.
Hello, ma'am, am I audible?
Perfectly, clearly audible.
Yeah, ma'am. So in the previous two classes, what we have done, so first class, we were just going through the algorithms and we were seeing the time complexities and how to calculate the time complexity. In the last class, we started with the asymptotic notations. So first we saw like what is the order of the priority, like what is the increasing order of the time complexity. So we have seen that constant takes the least number of time, and that is the most optimized code that we have written will be shown by the constant one. And the in case of polynomial or exponential or cubic, we can say that in that cases the situation becomes worse, and then it takes a lot of time to it takes a lot of computational time complexities to calculate all these things. So this we have seen, and we have seen some basic relations like how the log function and all those things, like in which case the time complexity is greater. So that we have seen, and in asymptotic notation we have seen the big O, omega, and theta. So we have also seen like the cases where we can include a constant, and how like Fn can be represented as the order of like a big O of Gn, like that we have seen, and theta also we have seen, and in which cases we can include a term C, and we can say that, okay, fine, the complexities can be written in terms of order of big O of n, or you can say that theta of n or omega of n, like that. So these only things we have seen, and we have seen some of the problems, and that's what we have done in the last test. Hello? Hello?
Hello, now I am audible, right? So now what we can discuss in today's class. So until so far, we have seen that what is the overall time complexity part, right? We have seen what is a priori analysis. We have seen that given a code, how we can compute any time complexity. All those things are perfectly clear to everyone, right? Now, in today's part, we try to discuss about the concept of recurrence relation. So this is our today's agenda. First of all, let's try to discuss about the meaning of the recurrence relation and how we can solve any kind of a recurrence relation. And then maybe by tomorrow, we will start our actual DSA portion where we will talk about, first of all, the data structure named array, and in depth, step by step, we will move towards that then after that. But in today's part, I think this is the last class for the analysis module that we have started, right? So we will discuss that what is something which we call as a recurrence relation and how we can solve this recurrence relation. Okay. Assignment questions I will discuss, it's okay, at the end of the class, we will discuss that as well, okay? Once we will complete this topic, after that, I will discuss whatever be the 5, I think, assignment problems I have given to you all. which is related to big O, theta and omega. Later on, I will ask from you, let's see who will be the students who will give me the correct response for these problems, right? We will discuss that maybe after, in the last 10-15 minutes, we will give a discussion about that. So let's get started. So first of all, whenever I'm talking about this recurrence relation, in today's session at least, forget about how this recurrence relation is coming up. We will discuss the creation of this recurrence relation when we will move towards actual algorithms module, where we start with the divide and conquer module. There you will see a lot of recurrence relation we will talk about. And at that point of time, we will see that how basically any recurrence relation is created. So what you will see today, we just need to understand in today's class that, okay, from somewhere some recurrence relation is there, we have created, how we can solve that recurrence relation in order to reach to the time complexity part, right? How we will be able to calculate any time complexity for a recurrence relation. That is the objective of today's class. How we create that objective we will discuss in our next upcoming classes. This part is clear to everyone, right? So in today's class, no one will get confused with the question that how we are getting this recurrence relation. Everyone's focus should be how we will solve this recurrence relation. There are two things: how we get this recurrence relation, another thing, how we are solving this recurrence relation to get the time complexity. So in today's class, we are focusing on our second portion. First portion we will discuss when we will move towards the actual algorithms module. I hope I am making a clear sense to everyone, right? So let's get started now. First of all, I'm just giving you a brief intuition about recurrence relation before starting that how we can solve that. There is something, the concept of recursion, which we have in our algorithms. And with the help of this concept of recursion, we will be able to solve too many problems. What does this recursion says? It simply says that whenever a function is calling itself, whenever a function is calling itself directly or indirectly. I will show you, don't worry, directly or indirectly. This is something which we call as recursion. What is the meaning of that? Is everyone aware about the factorial? How we can calculate a factorial of a number? For example, if I am saying that what is 3 factorial, so you will say to me that it will be 3 into 2 into 1. So it is something which is equals to 6, right? This is how basically we can calculate the factorial. If I will tell you that, can you give me a code for calculating the factorial, you will say to me that, okay, what I can do is that I will say factorial of n. So user will enter that number n, right? So this is something which I am saying is a function, which is fact of n. Function is something which is doing our task which we want, a purposeful task. For example, here the task of this fact is to give me a factorial. Inside that, I am saying one condition, that if suppose the number n, which is entered by the user, is equal to 0, or if the number n is equal to 1, then do one thing for me. What is that thing? Can anyone tell me? What is the factorial of 0 and what is the factorial of 1? Both are 1. Can I say? So I hope everyone knows that the factorial of 0 is also 1 and factorial of 1 is also 1. So we know this thing, right? We know this thing. This is something in terms of the language of data structure algorithm, or in terms of the language of algorithm specifically, I would say, called as the base condition. This is something which we call as the base condition, where we know that our code should terminate. So what I am saying is that when the value of n is equal to 0 or the 1, simply return the answer as 1. Because I know that at that point of time, the factorial will always be equals to 1. In else case, what will happen? In else case, obviously, we are saying that when the value of n is greater than 1, at that point of time, what will be the result? Result will be equals to Can anyone tell me what will be the result? What it should return? Or you can directly return it as, you can make a return statement by saying whatsoever the number you have, which is n, yes, everyone I think says it correctly, multiplied with, now I will call the same function again, which is a fact of n minus 1. Now here, if you will observe one thing, try to observe this function. First of all, what is recursion here? Here, if you will see, this is the function name, and I am calling the same function again inside here. Can I say? I am calling the same function here inside the code. So function is repeating itself. Fact function is repeating itself. Can I say this statement? Because the function is repeating itself, this is something which we can say is the concept of recursion. This is something which we can say is the concept of recursion. With a different set of parameters that we have, right? N minus 1. Yes, we can write one more condition that if the value of n is less than 0, at that point of time, just simply return with a 0. So negative numbers are not allowed at that point of time. But here we are considering that user is entering a number which is greater than 0, greater than or equal to 0. Okay. For that, we are writing this code. And this is something which I can say is not a proper code. I can say it's a pseudo code, right? Where we are just writing the logical assumptions which we want, if and else statement. Now, whenever you will be having this kind of a code where recursion is there, then there is always something which we call as recurrence relation of that recursion. Wherever a recursion is coming into picture, there is something which we always have is the recurrence relation. And for the recurrence relation, first of all, you need to create that recurrence relation for a recursive code. And after that, you need to solve that recurrence relation using any of the method. So there are 3 ways to solve a recurrence relation. One is called as substitution method. Second one is called as recursive tree method. And the third one is something which we call as Master's theorem. So these are the 3 methods with the help of which we will solve a recurrence relation, which will be created whenever we will be having a recursive code. Is that making sense to everyone? Is that fine to everyone? Now, how we can create that? Here, if you will see, suppose the time complexity required for the Sept code is T of n. So, can anyone tell me what is the time complexity required for this code? Who will tell me? Can I say it is constant C, which we can represent as big O of 1 as well? Can we say? Right? After that, it is, what is the time complexity for this code? Here, if you will see, what we are doing is that we are repeating the same function again. So you can write it as T of n minus 1, n into T of n minus 1. So whenever there is some function which is repeating, you are writing with the same term with a different set of parameters. This basically denotes that, okay, this is a kind of a recursion that we have. Now, the recurrence relation for the above code will be, you are saying that T of n, which is equals to, when the value of n is less than or equal to 1, you are saying that the answer is constant, which is C, considering that n value will always be greater than or equal to 0. And when the value of n is greater than 1, at that point of time, your recurrence relation will be n into T of n minus 1. This is something in this particular format, whenever you are seeing any of the relation, this is something which we called as, usually in the language of algorithms, called as recurrence relation. Now, whenever we are solving any recursive code, which we will solve a lot when we reach towards that divide and conquer algorithm module, at that point of time, for every code, whenever we are writing, we used to calculate what is the recurrence relation. We always do this kind of task. And you will be quite easily able to understand at that point of time. Even you are the only ones after 1 or 2 times when I will explain to you the recurrence relation, you are the only one who will give me the recurrence relation of the codes. But here the point to understand is that now in our session what we will do is that I will try to give you directly this kind of a recurrence relation. Okay, so you don't need to understand here that how this recurrence relation is coming. For example, here I have shown you how this is coming up, but in the upcoming examples which we will cover up in this session, I will directly write the recurrence relation, and then we will try to understand that how this recurrence relation we can solve using a substitution method. First of all, we will talk about this, then using a recursive tree method, then using a master's theorem. Then in our next upcoming classes, when I will give you any kind of a recurrence relation, you automatically help me to understand then what is the time complexity requirement for the same. Is this objective is clear to everyone? The today's agenda, what we are doing it here? Yes. Shall we start now discussing about the substitution method, how it will work? Perfect. Great. So let's get started with the very first method to solve any recurrence relation, which we called as substitution method, right? So whenever we are saying substitution method, substitution means we are trying to substitute the values here. Somehow you are trying to substitute the values here. How? So let me write one recurrence relation here. Example number 1. So here it is saying that when the value of n is equals to 1, means when the number of data points that you have is equals to 1, at that point of time it is taking a constant amount of time to solve the code. When the value of n is greater than 1, at that point of time your recurrence relation will be t of n minus 1 plus n. This is the kind of a recurrence relation that you will be having. Fine. So this is the recurrence relation that we have. Clear? Now the question is that this recurrence relation, how we can solve? Can you tell me what is the recursive term here? Who will tell me what is the recursive term in this recurrence relation? Anyone? N minus 1, right? Can I say that this is something where the function is calling itself? Where the function is calling itself. Can I say this is the recursive term? There is no background noise, at least at my part, because there is nothing going on at the background. So is everyone is facing the trouble in listening my voice? No. I think those who are facing the issue, please rejoin it again. Because at my part, everything is so much fine here. Okay, so this is the kind of a recurrence relation that we have. Now we need to understand that how we can solve it using the substitution method. Okay, so here we will be having t of n. So just focus on the recursive term that you have, which is t of n minus 1 plus n. Whenever we are solving it using a substitution method, what we are trying to do here is that we are trying to substitute the recursive term here. Always remember. So can you tell me what is the value of t of n minus 1? What is the value of t of n minus 1? If you will just substitute instead of n minus 1, can you give me the equation of t of n minus 1? Anyone? So just focus on this above equation. So this is the standard equation that we have, which is given to us. What I am saying is that focusing on the above equation, can you give me the equation for t of n minus 1? You just need to replace the value of n with n minus 1. So can I say it will be t of, when you replace this value of n with n minus 1, it will become n minus 1 minus 1 plus n minus 1, because n minus 1 will be as it is. So instead of n, I am just replacing it with n minus 1. So I will be able to get the value as t of n minus 2 plus n minus 1. Can I say? So if I will try to put this value of t of n minus 1 in the above equation, I will be able to get the value as t of n minus 2 plus n minus 1 plus n. Can I write? See this? Can we write this? Right? So this is the equation for the first time which is given to us. Second time when we did the imputation or substitution of the values, this is the second time the equation that we will be able to get. Plus n kaise aaya? Here if you will see, if you will just this value I just imputed, t of n minus 1 is the value where I did the substitution. So I will be able to get this value t of n minus 2 plus n minus 1. So this is the value of t of n minus 1. We are placing it in the first equation. Plus n will be as it is. Getting my point? Very simple. It's just a very simple mathematical equation if you will observe. I'm not doing something big here. I'm just trying to substitute the recursive term. That's it. Now, if I will ask from you, what is the value of t of n minus 2? Can you substitute again? What will be the value of t of n minus 2? Can I say it will be equals to t of n minus 3 plus n minus 2? Can I say this is the value of t of n minus 2 plus remaining things will become as it is n minus 1 plus n. Can I say this is the equation that I will be able to get? Right? So this is the equation that we will be able to get for the third time. So we are just trying to do the substitution here. First time, second time, third time. Now the question is, simple question is that how many number of times do I keep on doing the substitution? How many number of times do I keep on doing the substitution? Suppose I am saying that I will keep on repeating the same task k number of times. Now the question is, what is the value of k? What is the value of k? So now you have to see for which particular value you know the answer. You know that at the value of t of 1, when the value of n is equals to 1, your answer will be equals to 1. Do you know this? Because it is written that when the value of n is equals to 1, means when the value of t of 1, what is the value? It is equals to 1. We know pretty well. It means if inside this t bracket, if I will make this number as 1, I will be somehow able to reach to a solution. It means that I will keep on doing the subtraction. For example, initially I was having n minus 1, then I was having n minus 2, then I was having n minus 3. I will keep on doing this k times. So when I did the first time, I will be able to get n minus 1. Second time I was having n minus 2. Third time I was having n minus 3. When I am doing k times, so I will be having n minus k. And I will be doing the same task when I will be able to get the value as 1. When the internal value of t will be equals to 1, at that point of time I will stop. Right? Can I say this statement? Why 1? Because I know that at 1, this is giving me the answer as 1. Now here if you will observe, the value of t of n is something. Now can anyone tell me what will be the equation if I will repeat this particular task k times? Who will tell me? Who will tell me the equation if I keep on repeating the same task k times? What will be the equation of t of n? Can I say it will be equals to, so just you need to observe. For the third time when you are doing this this task, you're getting T of n minus 3 plus, how this equation you are getting? It will be nothing but is equals to n minus 3 plus 1. Can I write like this? This equation will be n minus 3 plus 2 and so on. So just understand, see this equation now. Can I write like this? N minus k plus n minus k plus 1 plus n minus k plus 2, and this will keep on going. At the very end, we will be able to get n minus 1 plus n. Can I write like this? Just observe the above equation and do let me know, can this pattern is following or not? Right? So when we repeat the same task k number of times, this is the kind of a thing that we will be able to get. Right? Yes, Hamid, what's your doubt?
Okay, it will be something like T of n minus k plus k into n minus k, isn't it?
What you are saying? Could you please repeat?
It will be something like T of n minus k
Yes.
plus k into n minus k, isn't it?
How k into n?
There will be n k's, so there will be n k's in the sequence.
So let me finish this. Don't solve this equation as of now. Just the pattern that we are following from the above one. Is this fine to everyone or not? The equation
Yeah,
I will solve and then we will discuss.
Yeah, sure.
Okay. We will solve this equation. Don't worry. But whatsoever steps I have showed you here, is that fine until now or not? Any doubt, anyone?
Yeah, it's fine for me.
Okay. Yes, Pranjal.
Hello.
Yes,
Yeah,
please
I
speak.
just want to know how n minus 1 plus n is coming. Means यहाँ पे वो होना चाहिए था ना, मतलब इसे
कहाँ पर
minus
बोल रहे
3
हो?
plus लास्ट में आपने जो tn equals to tn minus k लास्ट
हाँ.
टर्म जो है n minus 1 plus n, तो एक बार वो समझा सकती हैं आप?
So
n
this,
minus 1 plus n कैसे आ रहा है? हाँ.
so this is the last, what is the last part of your state equation? N minus 1 plus n, right?
मतलब लास्ट में तो ये आएगा ना n minus k, मतलब जो अगर tn equals to tn minus 3 plus n minus 2 plus n minus 1 plus n
So
है,
here
जैसे
you
ऊपर
will
आप
see
देखिए थर्ड टाइम आपने जो लिखा है
T of n minus 3
तो
की जगह दोबारा से substitute करो. What will be the equation you will be able to get?
होगा ना, तब n
When you will substitute the value of T of n minus 3, what you will be able to get?
t of
Can you
n
tell me the
minus
equation?
4, मतलब n minus 3 को सब्स्टिट्यूट करेंगे तो t n minus 4 plus
T of
n
n is
minus
equals to T of n minus 4 plus
n minus 3
n minus 3 plus
n minus 2
plus
n minus 1
plus
plus n.
So जब भी तुम सब्स्टिट्यूट करोगे कभी भी, तो ये तो आएगा ही ना, लास्ट वाली वैल्यूज शुरू से ही आएंगी ना. n minus 1 plus n minus 1 plus n.
अच्छा, हाँ ये फर्स्ट वाला रहेगा ना, हाँ ठीक है,
Right?
ठीक है, हाँ
So
वो कंफ्यूज
this
हो
is
गया
the
थोड़ा
fourth
सा.
time we are doing the substitution.
हम्म.
So when you repeat the same task until k times, so the last part that you have, last two terms I have written, this will come anyhow.
Yes.
Can I say?
हाँ, yes, you can say.
Right? Okay.
Yes. Thank you.
Now, I hope this part is clear to everyone, right? Now here, if you will observe, what is the value of k? We can calculate this value of k. So can I say that the value of k will be equals to n minus 1? Can we say? So what you can do now is that you can place instead of k, the value of k as n minus 1. So let me try to place it here. T of n is equals to T of n minus k is n minus 1. So what I'm doing here is that I'm placing the value of k, which is equals to n minus 1. So n minus k plus 1 is there. So I'm placing n minus 1 plus 1 here. Plus n minus 1 plus 2. Until so on, plus n minus 1 plus n. Fine. Fine. Yes. Palani Raj, is this your name?
Ma'am, am I audible?
Yes, please say.
Ma'am, I have doubt with the equation formation, ma'am. Like you have taken that T of n is equal to T of n minus 1 plus n, right?
Yes.
So are we doing n amount of work to reduce this equation by 1 unit?
What is your question? Are we?
Actually, we are just multiplying. You can go to the previous step, ma'am, and just you can scroll a little up.
Forget about this thing.
Here we are
Here I
multiplying
was just
n with
explaining
T of n
that
minus 1.
how
right?
we can create a recurrence relation. Forget about this. Here
Okay.
we started something new. So
Okay.
until this part, I was just showing to you that how we can create any recurrence relation. I just
Okay.
gave one sample example and I just showed you. After that,
Okay.
I just here from this particular page, I am showing to you how we can solve any recurrence relation. So I take some random example. So
Okay.
that's what
Okay.
I told you everyone that don't focus how this recurrence relation is coming up. Focus
Okay.
on somewhere this recurrence relation is there, how we can solve it using a substitution method. That's the objective.
Okay. Okay. Thank you, ma'am.
Fine? Okay. Why n minus k is equals to 1? See, at what point of time you know that this value, what is the solution you know as of now? You only know that when the value of t of this inside bracket, if this will be 1, then you know that the answer will be 1. So that's why you take this value of n minus k is equals to 1. So the value of k will come out to be n minus 1. Now you place this value of k as n minus 1 in every row. Now if I will solve this equation, what you will be able to get is t of n and n will cancel out with each other. So it will become n minus n plus 1. So it will be t of 1, right? Plus it will be, if you will solve this equation, it will be, if I will solve this completely, n minus n plus 1 plus 1. So I can write it like 2 plus 3 until so on. I will be having n minus 1 plus n. Now I know the answer of this particular thing. That's what I want. That's why I have placed the value of n minus k as 1. Can you tell me what is the answer of this t of 1? What is the answer of this t of 1? We know, right? So we know the answer as 1. So it will be 1 plus 2 plus 3 until the value of n minus 1 plus n. Right? Now what is this? Who will tell me? What is this equation? Can I say that this is something which is a sum of n natural numbers? Sum of n natural numbers. What is the formula of that? The simple formula of n natural numbers, which we used to study in our lower classes, is n into n plus 1 by 2. Simple. If I will solve this, it will be n square plus n by 2. So if someone is asking to you what is big O time complexity of this, who will tell me? By seeing this equation, which is having a higher term, n square. So can I write it like this? It is big O of n square. So this is how, using a substitution method, given any recurrence relation, you will reach to this big O time complexity. So this is the example number 1, which I want to discuss. And I hope that it will give you a greater insight that how basically with the help of a substitution method, we will be able to reach to a big O time complexity. So basically what we did is, as a summary, we just see what is the recursive term. Okay, we went there. We try to place that recursive term value. We will try to just substitute that value. This is the right term. That's why this name coming into picture, substitution method. Now we need to substitute it until k times, and we need to observe that what is this value of k. And each and every time you will be able to reach to this kind of equation that I have mentioned here. After that, you just need to solve this equation by mentioning the value of k that you will be able to get. After that, you will be able to get some kind of a series at each and every time. It might be sum of n natural numbers, it might be a AP series, it might be a GP series, it might be a factorial kind of a series, it might be a logarithmic kind of a series. According to that, you will be able to make an intuition that what is the overall big O time complexity of your code. How it is n into n plus 1 by 2? Because this is a series of n natural numbers. Sum of n natural numbers is n into n plus 1 by 2. If suppose it's a very basic math that we use to study this series, suppose I am saying what is the sum of these first 5 numbers? Either you can do the addition manually, 5 plus 4 is 9 plus 3 is this, or you can say that it will be 5 into, so it's 5 into 6 divided by 2. If you will observe, in both of the cases, answer will be same. So the formula will be n into n plus 1 divided by 2. How n minus k is equals to 1? Because here I need to see that what value should I insert here, for which I also know the answer, for which I will be able to get rid of this recursive term, for which I will be able to terminate my code. What is the base case condition? So I know that that value is nothing but is equals to 1, because I know that the value of t of 1 is equals to 1. So at this point of time, I will be able to get rid of my recursive term. At every time you need to see this. So this is the term for which it will give you the answer, and you will be able to get rid of this t statement, that recursive statement. So that's why we have put that value of n minus k is equals to 1. So that you will be able to understand that until how many times should I repeat this task so that I will be able to get rid of this equation. And this is what you did here. So you will be able to get the value of 1 inside. That's why you will be able to place that value of t of 1 as 1 here. Getting my point, everyone? Is this clear? Fine. Okay, so if it is fine, let's talk about another question. It will be much clearer. If there is any doubt to anyone, don't get demotivated. We will solve numerous examples and questions, and then I will give you this assignment problem as well. So don't need to worry, but please pay attention. Towards every example, you will understand something good here. Example number 2. Let's talk about that. Example number 2. So here we will be having the value of t of n, which is equals to, if the value of n is equals to 1, it will be equals to 1. If the value of n is greater than 1, it will be equals to t of n minus 1 plus 1 divided by n. Just solve this. Try to solve this. Let's see who will be able to give me the correct answer. So solve this using a recurrence relation. What you need to do is that now you have this. This is the recursive term, right? This is the recursive term that we have. So you need to substitute this recursive term now. So you will be having the value of t of n as t of n minus 1 plus 1 divided by n. This is the first time you will be able to get this equation, right? Now, second time when you do the substitution of t of n minus 1, check what is the value you are getting. Check for the third time as well. Then check how many number of times you need to repeat this task. What is the value of k? Then you will get some series and then give me the answer. What is the big O time complexity for this? Try to solve this question. I am giving you maybe 5 minutes of time, and let's see who will be able to give me the correct answer. Hello. Hello, hello. Is my voice is coming? Okay. Now it is better or it's not better? Vidiko. Hello, hello. Is voice coming now? Yes? Perfect. Now is someone, can anyone please speak now? Grijesh, anything, can you speak?
Yeah, hello.
Perfect. Yeah, now it is fine for me
Yeah,
as
thanks.
well.
Cool.
Great. Yeah, it was audible before too, but it was not working through this mic. It was working through earphone, and that's why you guys are getting the echo as well, I think. But now I just reconnect my this cartlet, and then now it is working fine, I think. Great. Okay, so I think meanwhile, have you solved this question? Log of n. Okay. Many students are getting log of n. Okay, let me give you 1 more minute. Then I will discuss the solution. I feel log of n is correct. But let's see. I also don't know. We'll solve and then we will see whether we are getting log of n or not. Any other student who is getting the answer apart from log of n? Grijesh, what you are getting?
A decreasing series means it's 1 plus 1 1 divided by n minus 1 plus 1 divided by n minus 2 and so on.
Okay, so what is this series? This is a series of?
This is not a series of log n. This is I'm sure.
Okay, let's see. Okay, let me now try to solve this question. Perfect.
let's get started. So here, moving towards the t of n minus 1 substitution. So can I write at the second time, the value of t of n can be written as t of n minus 2 plus 1 divided by n minus 1 plus 1 divided by n? Can I say? This is the equation that I will be able to get for the second time. Perfect, everyone? Right? Okay, let's move ahead. If I will substitute for the third equation, what I will be able to get? I will be able to get the value as t of n minus 3 plus 1 divided by n minus 2 plus 1 divided by n minus 1 plus 1 divided by n. Can I write like this? Third equation for the third time. Perfect. Okay. If it is fine, the question is, how many number of times should I repeat this task? So assume that we are repeating this task until k times. So at the k time, what will be the value of t of n I will be able to get? Can I say it will be equals to t of n minus k plus 1 divided by, if you will observe, this term is nothing but n minus 3 plus 1. Can I say? This term is nothing but n minus 3 plus 2. So I can write it as n minus k plus 1 plus n minus k plus 2 until so on. The last two terms can be equals to 1 divided by n minus 1 plus 1 divided by n. Can I write like this, everyone? Now the next important thing we need to understand is that what should be the value of k? What should be the value of k? For that we need to see what is the base case condition where my code is terminating and I will be able to get rid of this t term. So let me check my recurrence relation again. It is 1. At 1, my value will become 1. The simple meaning is that when the value of n will become 1, which is t of 1, it will be equals to 1 here. Perfect. So now I know that when the value of n minus k is equals to 1, I will be able to reach to a point where I will be able to get rid of this t equation. So what will be the value of k according to this? The value of k will be equals to n minus 1, right? So now what I can do is that I will try to place this value of k as n minus 1 in my equation. So t of n is equals to t of n minus 1 plus 1 divided by n minus 1 plus 1 plus 1 divided by n minus 1 plus 2 until so on plus 1 minus 1 plus 1 by n. Can I say? Everyone? Try to see this equation. Is this perfect fine, everyone? Now if I will solve this equation internally, it will be n minus n plus 1. So it will be equals to t of 1. It will be n minus n plus 1 plus 1. It will be 2. It will be n minus n plus 1 plus 2. It will be 3. Meaning what I want to say here is that, can I write like this? T of 1 plus 1 by 2 plus 1 by 3 until so on plus 1 divided by n minus 1 plus 1 divided by n. Is everyone getting the same kind of equation? Yes? Now this t of 1, we can write it as 1 because now we know the answer of t of 1, which is equals to 1 plus 1 by 2 plus 1 by 3 until 1 by n minus 1 plus 1 by n. Can I say? This is nothing but is a series of a logarithmic series. So it is big O of log of n. This is a series of logarithmic series, and that's why the time complexity will be big O of log of n. Yes. Can I say this is a series of logarithmic series? 1 plus 1 by 2 plus 1 by 3, 1 by 4, 1 by 5 until 1 by n. So today, if there is someone who don't know about the AP series, GP series, logarithmic series, exponential series, right? Try and go there on the web that what is the different kinds of series that we have. Just check once. Might be you guys have already did these things, but after there must be some gap between this mathematical side what we did. It's just a 10th 12th maths that I'm talking about here, not more than that, right? What is this? What is this? Okay, perfect. Now let's talk about another question. I think one recurrence relation which we have talked about in our above part is this, right? So now we will try to solve this kind of a recurrence relation. So example number 3, let me try to give to you all. So what you're supposed to do here is that the value of t of n is equals to, if the value of n is equals to 1, I am saying the answer is 1. If the value of n is greater than 1, the answer is n multiplied with t of n minus 1. Let's see who will give me the correct answer. Everyone, please try to solve. Again, using a substitution method, you need to solve this. Obviously, the more you will be able to get the correct answers, so it means that you will be getting a better understanding of the approach that I am discussing in the live class. And you don't need to spend so much of time after that. This can't be a recurrence equation. Palani Raj, what do we mean by that? Can you just raise your hand? I will unmute yourself. I will unmute you. Yes, please say.
Am I audible, ma'am?
Definitely. Please ask. What's your concern?
Ma'am, here, actually the time complexity is reducing by 1 unit, ma'am, but it is again getting multiplied by n units. So, which will be greater than the TFN. So, we can't say this is an reduced from the previous step.
Which question you are asking, first of all? Is this new question which I gave to you?
Sorry, ma'am, I can't hear you.
Am I audible?
Yes, ma'am.
So, which question you are asking here? Is this example number 3 or you're talking about example number 2 only?
No, ma'am. Oh, just a second. There is some problem with my speakers. Just give me a minute.
Meanwhile, those who understood, please solve the equation
Ma'am, am I
and give
audible?
me the answer. Yes, you are audible.
Yes, ma'am. In the third example, ma'am, you
Yes.
have given us for when n is equal to 1, the output will be of 1, which means it is a constant unit of time. And in that, if n is greater than 1, it is getting divided into t of n minus 1 multiplied by n times, right?
Yes.
So how can this be lesser than that, which is actually the t of n? This can't be lesser than the t of n. I am afraid that this can't be lesser than that.
Means I am not getting your question at all.
Actually, we
That's the
are
thing.
approaching using recursion to reduce the units by each step, right? Actually, the time will be reduced and the inputs amount will be reduced. So let's say, if, for example, we are calculating for an 10 inputs. In first step, it will be 10. And here, in the next step, after
so basically, let me give you a justification of this. For example, n is equals to 5. So what we
Okay.
are saying, value of initially it will be 5 greater than 1. So it will be
Okay.
t of 5, which is equals to 5 into t of 4. Can I say?
Yes, ma'am.
After that,
Actually, it is
we will
5
solve
times the
this.
T of 4, right?
Yes, we will solve this. So what will happen? This will be equals to 4 into t of 3.
T
Can
of
I
3,
say?
okay.
After
Yes.
that, what will happen? This will be 3 into t of 2. Can I say?
Yes.
After that, it will be 2 into t of 1. Can I say?
Yes.
And when it will be equal to 1, answer is 1. So it will be
Okay.
equals to 1.
Okay.
So now this is t of 2. The value of t of 2 will be equal to 2 into 1, 2. So 3
Okay,
into 2
2.
is 6. So 6 will be returned.
Okay.
6 into 4 is 24. 24 will
Okay.
be returned. 24 into
Okay.
5 is 20, 120. This is
Okay.
the answer. So this is the factorial recurrence relation that we just talked about few minutes back.
Yes, ma'am. This can be termed as in a function, right? So this T is referring to the time taken by that
Yes.
particular module.
Yes.
So I thought that when we are just reducing that input by 1 unit, so which is T of n minus 1, and we are multiplying that with n units. So 9 into 10 will be 90, right? So the time taken for
Not 9 into 10. This is the
Okay.
same function which is calling itself. So here recursion is happening.
Okay, this is the time taken for calling n minus 1 units, right?
Yes.
Okay.
So here recursion is happening. So here what you are
Okay.
trying to do is that you are trying to call the same function with lower value again and again
Okay.
until you reach to this condition which we called as a base case condition.
Okay. Okay.
Anyhow, if someone is not able to get an idea of how basically this recurrence relation is created, as I
Okay.
told you in the starting of the session, don't worry about that part because we will solve almost 30 or to 50 questions in our
Okay.
divide and conquer module.
Okay.
At that point of time, you will see that how we can create this recurrence relation. In today's session, just focus on how we are solving this recurrence relation. Because
Okay.
today, if you will miss that part, after the today's session, I will not discuss that how substitution method will work.
Okay. Okay.
Okay. So don't worry
Okay.
about these things. We will talk
Okay.
about all these things in very much depth in upcoming classes. That's the only thing that we will talk.
Okay.
In almost all the upcoming sessions, 5 to 6 sessions, we will give towards this part only.
Okay, ma'am.
But today is the only session which I will give towards discussion of how we can solve recurrence relation using a substitution method.
Okay.
Right?
Okay.
Okay. Now
Okay.
try to
Thank you,
solve
ma'am.
this recurrence relation and do let me know
Yeah, sure, ma'am.
what is the answer you guys are getting. So someone is saying n factorial, someone is saying n to the power n. Okay. Shall I solve or everyone has tried? Or shall I wait for a few more minutes? Very good. I am seeing almost everyone's answer as correct. Whatsoever answers I have seen, because there are so many students who are doing a chat, but at least whatsoever I have seen as of answers, everyone is correct. One more minute, I am waiting. Perfect. So now, let's see. Let me try to solve this question now. So this is the last example which I will discuss. After that, I will give you as an assignment problem to solve it at your home, because the approach wise, everything is same. It's just that how good you are in doing or in seeing a series kind of a thing, with the help of which you will be easily able to get the answer, right? So approach wise, I think I'm making sense with every example. So let's get started. So here we will be having T of n, which is equals to, what we have is n into T of n minus 1, right? Okay, perfect. Now, if I will try to do the substitution of this word T of n minus 1, what I will be able to get? T of n, which is equals to, can I say it will be n into n minus 1 into T of n minus 2? It would be better if I will do the just reverse of the same equation, so that it will be much simpler to see, actually, to me. So what I'm doing is that I'm writing recursive term up front, because we need to do the substitution of that term, no? So n minus 2 into n minus 1 into n. Can I write like this, everyone? Is everyone following me? Is this fine until now? Now, third equation, what we will be able to get? N minus 3 into n minus 2 into n minus 1 into n. Can I say? Is this correct, everyone? Perfect? Okay. So now the question is, how many number of times we need to repeat the same task? Suppose we are saying that we will repeat the same task until k times. So what is the value of k? What is the value of k is our next task. So n minus k, which is equals to 1. Why 1? Because we know at 1 it is constant, 1. Perfect. So now the value of k will be equals to n minus 1. So we will place the value of k at n minus 1, but before that we need to bring that equation. So when I am repeating this task until k number of times, we will be able to get the value of T of n, which is equals to T of n minus k plus the value of n minus k plus 1. Can I write like this? Because here, if you will observe, this is nothing but is equals to n minus 3 plus 1. This is nothing but is equals to n minus 3 plus 2. So can I write like this? N minus k plus 1 into n minus k plus 2 until so on into n minus 1 into n. Can we write like this? Now here, if we will place this value of k as n minus 1, what we will be able to get? We will be able to get the value as T of n minus 1 plus n minus 1 plus 1. Not plus, multiply. N minus 1 plus 2. Multiply. So on, multiply n minus 1 into n. Now if we will solve this equation internally, it's very simple. N minus n plus 1. So it will be T of 1. It will be equals to n minus n plus 1 plus 1. So it will be equals to 2. It will be equals to n minus n plus 1 plus 2. It will be equals to 3. So basically, if you will observe here, we will be able to get the value as T of 1 into 2 into 3, right? Until into n minus 1 into n. And we all know that the value of T of 1 is something which is equals to 1. So here it is something which is equals to 1 into 2 into 3 into until so on into n minus 1 into n. So here, if you will observe, what we are trying to do is that, for example, if suppose I am saying 5 factorial, what is the value of that? 5 into 4 into 3 into 2 into 1. Can you say this is a series of factorial where it is starting from n and it is keep on decreasing until the value of 1? So I can write it as n factorial. So it is nothing but big O of n factorial. Is this fine to everyone? Now, if you remember that complexity classes, in that I have discussed that there is something called as n to the power n. So there are some students who were writing that n to the power n. I will say that answer is also correct. Why? Because if you remember, the value of n to the power n is very much higher as comparable to n factorial. So if we will be able to get this time complexity as big O of n factorial, we can also write it as big O of n to the power n as well. But this is the more optimized version, I would say, n factorial. Any doubt, anyone? Is this simple? Now, are you able to understand how basically, given a recurrence relation, we can solve any question using a substitution method, the very first method that we have discussed today, where mainly what we need to do is that we need to substitute the recursive terms until we reach to a point which is called as k. So how this n to the power n? For this, you need to refer that complexity classes session, where I have talked about that what is the relationship between n factorial and n to the power n. If you remember in my those notes, if I will show you also, I think I can show you, I have the saved files. So if you guys remember, there I have discussed in lecture number 2, I think. If you will see, we have discussed this relationship. First, 8th point, n factorial is less than n to the power n. So if n to the power n is something which is bigger than n factorial, so can I write it in a big O terms? This is consider it as a f of n, it has g of n. So what is the equation of big O? It will be less than equals to c times g of n. Here you can consider the value of c as 1 also. So we can write this equation, right? It's just choice. This is the answer. But this answer can be written like this as well. This is what I'm saying. Perfect. So now everyone, I think, will be able to get an idea that how we can solve a substitution method. Now, the next method which I want to discuss in today's class for solving a recurrence relation, at the last, I will give you the assignment problems. So that is something which we called as a recursive tree approach. Recursive tree approach. Shall we start now? So this is the second method. Given a recurrence relation, how we can solve any of the recurrence relation using a recursive tree approach. Fine to everyone? So first of all, you need to understand here that at what point of time should we go towards this recursive tree approach. The simple thing is that whenever you will be having more than one recursive term, whenever you are having more than one recursive term in the recurrence relation, you should go for this recursive tree approach. What is the meaning of the same? Let's try to understand with the help of one example here. For example, here if I am writing like this, T of n, which is equals to T of n by 2 plus T of n by 2 plus n. So what is the base case condition? Again, I am saying that, so let me write it like that only. So I am saying that when the value of n is equals to 1, answer is 1. When the value of n is greater than 1, I am saying T of n by 2 plus T of n by 2 plus n. This is the question that is given to you. Here, if you will observe, you will be having two recursive terms. Although you can write it like this as well, 2t n by 2 plus n, and you can solve it using a substitution method as well. For this question specifically, I'm saying, right? You can solve it using substitution method as well. Can you solve it first of all? Who will give me the answer? T of n is equals to 2t n by 2 plus n. Can you guys solve it and give me the answer? What is the answer you guys are getting? Let's see who will give me the correct answer. Order of n. What about others? Only one correct answer, I believe, which is n log n. So n log n is the correct answer. Yes. So here, if you will observe, if we will try to do with the help of a substitution method, so what will happen? At the first time, you will have this equation, T of n, which is equals to 2t n by 2 plus n. So at the second time, if I will try to substitute this value, T of n by 2, what I will be able to get? Who will tell me? So take it as an assignment problem. Let me not solve it as of now. I will give you some time. Maybe we will solve this tomorrow. So the correct answer which you will be able to get for this question is n into log of n. See how you guys are getting, right? So this is, so let me write it on the, let it write here itself. So this is the assignment problem 1 of the substitution method, where you need to solve the value of T of n is equals to, when the value of n is equals to 1, result is 1. When it is greater than 1, what I am saying is that it is equals to 2t n by 2 plus n. And here you should get the answer as, so I'm giving you the answer as well. It should be big O of n log n. So let's see the approach. By tomorrow, I'm giving you time. Try to do this. Again, same thing you need to do. Try to substitute it, this T of n by 2 value until k number of times. You will for sure will be able to get some series of logarithmic kind of thing to get this result. But as of now, so this thing can be done with using a substitution method also. But what we are discussing here is the recursive tree approach. So for this question, how we will be able to solve this using a recursive tree method is what we are discussing here. So what you can do here is that, so if you will observe here, what we are trying to do here is that we are having n numbers. We are trying to split those numbers into two parts. N by 2 will go towards one side. N by 2 will go towards other side. And the cost required to do the split is something which is equals to n. See the equation again. T of n, which is equals to T of n by 2 plus T of n by 2 plus n. So how basically you need to understand this equation is that you will be having complete n numbers, right? You divide those numbers. There is something which we will discuss in our upcoming classes called as divide and conquer. And this approach says that divide the problem into various sub-problems. And that's what we are doing here actually. Here, if you will see, consider that we will be having a data. We will be having a data structure which contains n records. And we are trying to split our data into two halves, n by 2, n by 2 each. And now this n is showing us that what is the cost required to do the split into n by 2 and n by 2, which is nothing but n. This is how basically you will interpret this equation. Now, what will happen is that further again, what you will do is that for the left side again, split will happen. Now, if I will repeat the same task, again, if you're repeating the same point again, as Aman is saying, so what I'm saying is that we are trying to split this n data points into two parts. So there are two recursive terms that we have, right? What is recursion? Solving the same, calling the same function again, and then we are trying to solve it simultaneously. These two recursions that we have. So we are trying to divide our n data which we have into two parts. One is at the n by 2 side, another one is also n by 2. It means suppose you will be having 100 records. So what I'm saying is that you split those records into 50 and 50. That's what you did. And then you try to solve it simultaneously. Now, when you are doing a splitting of these n records into n by 2 and n by 2, there is some cost associated with that. What is that cost? Which is equals to n. This is the given by this equation, n. What is the operation? What is the cost required to split that is n. Now, if you will see, if you will repeat this task again, by doing a further split into n by 2, again it will get splitted into another level. Now, what is the value at the left side? If you will repeat the same step, so n is getting splitted into two halves, n by 2 and n by 2. So if you will split n by 2 into two halves, you will be able to get, can I say, n by 2 to the power 2 here, n by 2 to the power 2 here. Similarly, if you will split this also, you will be able to get n by 2 to the power 2 here and n by 2 to the power 2 here. How much is the cost required to split this thing? If initially, when you have n data points, the cost requirement was n, right? So when you're having n by 2 records, it will be n by 2. And this is also n by 2, right? This is something which I am creating here is called as a recursive tree. Recursive tree. Because here, if you will see, a tree kind of a structure is formed, where if you will observe, this is something from where you are starting is in a tree language, it is called as a root node. And when you're going down, this is called as levels. This is level number 1, level number 2, level number 3. You are going step by step down, 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 down. Now the question is that, okay, you will, so what is the cost, total cost required in level number 2? What is the total cost required in level number 2? It will be n by 2 plus n by 2. So can I say in total it will be equals to n? So in second level operations also it is taking n cost. Again, you will do the further split. Now the question is that until how many number of times should I do the same kind of a split? Suppose I am doing the same thing until k number of times. I am doing the same splitting until k number of times. At every time, so here if you will observe, what is happening is that this is the first time. So if you will observe, this is the first time we are doing a split into n by 2, n by 2. Second time n by 2 to the power 2, n by 2 to the power 2. If you will repeat the same task for the left side, k times, you will be getting n by 2 to the power k. And you will keep on repeating this task until you will be able to reach to a solution which is equals to 1. Because we know that when the value of n is equals to 1, at that point of time, solution is 1. So when the value of inside this t, if the value will become, when it will become 1, when the value of n by 2 to the power k is equals to 1. For the left side. For the left side node, I am saying. Similarly, for the right side node also, if you will observe, if someone is not getting, please have patience. We will discuss few more examples. After that, you will be able to get a much better clarity of this recursive tree approach as well. Initially, as an initial point, it seems somewhat difficult, but after discussing few questions, it will be very easy for you all. You will be able to understand, or your mind will be able to understand the pattern of this recursive tree approach. Now, on the right side also, we are doing a split of n by 2, n by 2. So it will be nothing but is equals to n by 2 to the power k, which is also equals to 1. Why I'm writing 1? Because we know that this is the base case condition where t of 1 is equals to 1. We all know. So until this point of time, I need to reach. So with the help of this, I will be able to calculate the value of k. So the value of k is equals to n is equals to 2 to the power k. For the left side, if I will calculate by taking a log base 2 on both sides, log base 2 to the power k. So k can be taken upfront. So k log 2 base 2 is equals to 1. So the value of k is equals to log of n base 2. Similarly, if you will try to solve the same equation on the right side as well, you will be able to get the value of k as log of n base 2. It means, what is this indicating? That if you will repeat this splitting of the nodes into two sub-halves until k number of times, where the value of k is equals to log of n. So until log of n base 2 times, if you will repeat this task, you will be able to reach to a solution where you will be having a single n equals to 1 node. Here, at every level, what is the cost associated with that? It is n. It is n. At next level also, it is n. So when you will reach to log of n level also, the cost is n. So what is the overall time complexity for this? The overall time complexity will be equals to the summation of all these levels, which you can say is how many number of levels that we have? Log of n base 2. For a single level, what is the cost? N. So the overall time complexity will be equals to big O of n into log of n base 2. It is nothing but n into k, where k is the number of times we used to repeat this task. Again, I'm explaining the same thing again. Please pay attention. See, first of all, what we have understood that we should go for this recursive tree approach only when we will be having a more than one recursive term. This is the very first point which you need to understand, right? We got it. So here, if you will observe, this is the first recursive term and this is the second recursive term that we have. That's why we can solve this question using a recursive tree method. Now here, if you will see, what is happening is that we will be having a record size n, and we are trying to split this n into two halves. What is the meaning of that? The simple meaning is that you will be having two recursive terms here. So if suppose you will be having a 50 records, 50 data points that you have, And if you will split those 50 records into 2 halves, because you are applying 2 recursion here. So 25 records, suppose you are doing a task of maybe factorial finding. Okay. So you have split your data into 2 halves. Or maybe suppose you are trying to do a task of finding out a maximum or minimum. Maximum, let's say maximum. Suppose I am giving you records of 50 data points. Your task is to find out of this 50 elements that you have, you need to find the maximum. Okay. So what you did is that you split your data into 2 parts. One part of the function contains first 25, 1 to 25 numbers. Another part will contain 26 to 50 numbers. So here also you will be having a 25 numbers. Now, every part is having the responsibility to find out the maximum. So what will happen? Suppose in 1 to 25 numbers, there is maximum number is 70. And here the maximum number is suppose 90. Individually, these 2 parts, we will be applying a recursion, and every part is responsible to give me the answer of a maximum number. So it is having a unique 25 numbers. It is having a unique 25 numbers. So it is giving me the number 70. Here it is giving me the number 90. And then when it will go back to the root node, what it will try to compare, it will just compare the number between 70 and 90 and will give me the result 90 as the final answer. This is how basically recursion will happen. Now in our case also, what we are trying to do is that we are trying to split our number of records into 2 halves, n by 2 and n by 2 each, given by my recursive tree. Now, always remember, whenever you are doing a splitting into 2 halves, there is something called as function f of n, which is basically responsible to find out that what is the cost required to split these numbers into 2 halves. And that is equals to n here. Now, what will happen is that at each and every time, this recursion will happen, and it will keep on repeating these numbers by 2, by 2, by 2, by 2 on left and right side. Until what point of time this task will keep on repeating? Until it reach to a base case condition. This is a base case condition. This is a base case condition. So it means that until or unless this internal value will be equal to 1, I will keep on doing this task. So what is happening is that at every time it is by to the 2 to the power by 1 is adding. So when you are reaching towards the third level, it will be n by 2 to the power 3. So when you're repeating this task until k times, you will be able to get the value as n by 2 to the power k, which should be equals to 1 for the left side node as well and for the right side node as well, because you're repeating the same task on both of the sides. Then you will be able to get the value of k. Here k indicates that how many number of levels should I move on in creating a recursive tree. So once you will be able to get that value of k, now you need to see that every level, what is the cost required to the splitting. Here, if you will observe that at every level, you are using n cost. So what is the total time complexity required to execute this task? It is nothing but is the summation of all the records that you have. So it will be n plus n plus n plus n plus n until how many times? Log of n times. So what is the overall cost? It will be nothing but the value of the number of levels multiplied by the, at each level, what is the cost? So it is n into log of n base 2. That is the complete recursive tree approach. Let me try to discuss one more example with you all. With this, you will be able to understand. Cost thing is something like it's for example, in our, so you are trying to split your data into 2 parts, right? N by 2 and n by 2. Or maybe, for example, n by 4, and here it is something which is n by 5. So you can consider that obviously when you're splitting your n number of records into 2 parts, there is something which is going on internally for this particular splitting portion. There is something which is responsible for this. What is that? The operations. Yes, you can say how many operations internally it is happening. So it will be something which can be equals to n, which can be equals to n by 2, which can be equals to n by 4. It is given in your recurrence relation itself. So after that, you will keep on repeating the same task until how many number of times that you need to calculate. Let me discuss one more question. I think after that you will get a better clarity, because here we are discussing a question in which left and right, both of them is having a same number of records. What will happen when both left and right will be having a different records? That will give you a different clear-cut idea about recursive tree approach. For example, let me discuss one more question here. Just give me 1 second. Okay, so let's get started now. Let's discuss the second question. And I believe after that, those who still have the query of how recursive tree approach will work, those doubts will get clarified. If still after that also there will be doubts, then I will be taking step by step all the doubts. I will not cover up Master's theorem. I think that will be too much for you all. So let's take it really slow so that everyone will be able to, grab the points. Again, why each operation we have n? That you will be able to understand once you will be able to understand that how we are creating a recurrence relation. And as I told you, that point we will discuss just after 2 sessions. Just wait for 1 or 2 sessions. After that, this point also I will clear-cut explain to you everyone. But as of now, I can't explain to you because you don't have the prerequisites required, that understanding requirement. Firstly, I will make you all clear that point, and then I will talk about this why thing also, that how this recurrence relation is forming up. Everything will get clear. But in today's session, please try to focus on that if given a recurrence relation, how we can solve that using a substitution method, how we can solve that using a recursive tree approach. And even there is one more method called Master's theorem. I'm not sure that I will be able to complete that by today. I think we can discuss that tomorrow. But let's talk about the another question also, so that it will get a better clarity to everyone. So here again, we are having a T of n. If the value of n is equals to 1, again, constant time. When the value of n is greater than 1, it will be something which is equals to T of n by 5 plus T of 4n by 5 plus n. Do one thing. First of all, try to solve it on your own. Take maybe 4 or 5 minutes. Let me give to you all. Whatsoever understanding you got with the one example which I have discussed, according to that, do this thing. So here we are having this n data points, and we are trying to split it into 2 parts. So let me get started with you all, and then I will give you the question. So here it is n by 5 on the left side. On the right side, it is 4n by 5. And you can see that the number of operations or the cost required to do the split is something which is equals to n. Given to me. How it is forming up? Just wait for 2 or 3 sessions. Please believe me, you will be able to get. But now, again, the split will happen. Who will tell me on the left side what will be the value? N by 5 to the power 2, can I say? One common thing that you need to understand here is that it's very simple. Please pay attention. You will be able to get that. Those who are not getting, it's very simple. If you will observe on the left side, every time what we are doing, we are multiplying the value. So let me write it here clearly. On the left side, at every time we are trying to multiply the value with 1 by 5. And on the right side, what we are trying to do is that we are trying to multiply the value with 4 by 5. So on the right side, what you will be able to get? You will be able to get the value as 4n by 5 square. On the left side, what you will be able to get? 4n by 5 square. Just following this pattern only, nothing else. On the right side, I will be able to get 4 square n by 5 square. See this? What is the cost required to split it into 2 halves? It will be n by 5. It will be 4n by 5. Because initially also it is exactly the same, right? What is the total cost? It will be 4n by 5 plus n by 5. Total cost will be, the second level, it will be 5n by 5. So it will be equals to n. Now solve it further and give me the answer. So one answer I got as n into log n base 5. Any other answer? Now see, maximum students are saying base 5. Although I know that in big O, base doesn't matter much. But let's talk about that thing also, because I don't want anyone to grab a wrong concept here. Please focus here now. Okay. So again, if I will go ahead towards the left side and the right side, it will be nothing but n by 5 to the power 3. It will be 4n by 5 to the power 3. Similarly, you know how you will be able to get the values at left and right. Here, if you will observe, what we are doing is that at left side, if I will try to find out the number of levels, right? It will be n by 5 to the power k, which is equals to 1. Can I write, everyone? Can I write this? Because at left side, if you will observe, at every time we are dividing it by 5. So if I will solve this equation, I will be able to get 5 to the power k. So let me write like KL, which indicates the left side levels. Okay. So if I will take the log base 5 on both of the sides, so KL left side level is log of 5 base 5. So it will be equal to 1. So on the left side, the number of levels that I will be able to get is log of n base 5. Can I say? Can I say, everyone? Yes, perfect. Who will tell me what is the value of KR? Means on the right side, what is the value of KR? Who will tell me? See now, can I write this on the right side that we are doing n divided by 5 by 4 to the power k equals to 1? Can I write like this? Observe. Simple maths. I'm not using any advanced mathematics here. Those who think that there is so much maths, this is a very basic maths which I am using. Can I say what I did here? Whatsoever be the numerator part I have, I just take it down in order to make it easier for me. That's it. Now, if I will solve this equation, which is n divided by 5 by 4 to the power k, which is equals to 1. So this is equals to, n is equals to 5 by 4 to the power k. Now, if I will take log base 5 by 4 on both sides, I will be able to get log of 5 by 4 and base is also 5 by 4. So I can write it as KR. KR is right side level. No audio? Am I audible? Hello? Don't say I'm not audible. I was explaining so much of things and you guys are not listening, then I got shocked. Okay. So here, if you will see log 5 by 4 and base is also 5 by 4. So this is something which is equals to 1. So we will be able to get the value of k of r as log of n base 5 by 4. Perfect? Everyone? Perfect. Now who will tell me which one is bigger? Because we have to anyhow think about a worst case scenario. So if we will be able to cover up the bigger level, automatically lower one will automatically be covered up. So who will tell me which one is bigger? I have discussed this in my complexity classes. So you can't tell me I don't know logarithmic properties. Left or right? Someone is saying left, someone is saying right. There is a competition going on. Left, right, left, right, left, right. If you remember, one line I gave you in the last session, that logarithmic works something opposite. Lower the base, higher the value. You remember this line? Lower the base, higher the value. So here, which particular base is lower? Left or right? Right is having a lower base. It means that this is the term which is greater. This is a term which is greater. So it means that this is the higher level. So if we will be able to cover up that higher level, automatically we don't need to worry about the lower level then. Okay. So we are good with the number of levels. Now at each level, how much is the cost? At each level, how much is the cost? N. So what is the overall time complexity? So the time complexity will be equals to order of n into kr, not kl. So it will be equals to order of n into log of n base 5 by 4. Anyhow, you can say that you can also write it as n log n. That's fine, because we can write, we can always talking about approximations, right? But here, if you will observe, this is the precise answer, I would say, to the question that we are discussing today, right? We'll discuss the logarithmic properties. It's okay. I am here only. You guys are also here. Don't worry. We'll discuss everything. But whatsoever I am sharing here or talking here, I have already discussed in my last class. Whether it's talk about the lower base and higher, lower base, higher value, all these things we have discussed. Fine, everyone? Any doubt in this question? Question number 2 that we have discussed? No doubt? So now what I can do is that let me give you one more problem. You guys will get comfortable after few more sessions. It's just the first class, and if you are getting comfortable, it's something very good job that you are doing here. Okay, perfect. This is the last example which I want to discuss before ending this class. Obviously, don't worry, we will discuss the doubts after that and the problem in the questions which I gave to you. But this is the last part of our today's session, which is the question number 3. So here, last example, tree of last example, which thing, Prachi, you want me to explain again? This point? So basically, if I will repeat this part again, here if you will observe, we will be having n data points. What we are trying to do is that for these n records, we are trying to split those records into 2 parts, n by 5 and 4n by 5. How you will be able to get to know? Recurrence relation is given to me. How this recurrence relation is formed, that we will discuss later on. What is the cost required to do the splitting? It is n. Again, it is given to me. So what we are trying to do is that at each and every time, on the left side, we are trying to multiply it with 1 by 5. On the right side, we are multiplying it with 4 by 5. We are keep on repeating the same task, right? Until the value will become equals to 1. Why 1? Because this is the base case condition which is given to me. That when the value of n is equals to 1, at that point of time, the value of t of n is equals to 1, right? So we are trying to find out the number of levels on the left side, because we know the pattern that it is keep on dividing it by 5 by 5 by 5. So we will be able to get the value of the number of levels as log of n base 5 on the left side. And on the right side, we will be able to get the value of log of n base 5 by 4. Once we will be able to get these two values, we will see that which one is greater. So we know that the lower the base, higher the value. So this particular value is greater. Right side is greater. After that, for every particular cost, every particular level, what is the cost? It is n, right? Now, if it is n, so basically, what is the overall time complexity? It is n into the greater number of levels. So it will be log of n base 5 by 4. Perfect. The last example of today's class. And that will give you a much better insight of the same approach that I'm talking about here. Okay. So what this example is saying, let's talk about that. It is saying that the value of t of n is something which is equals to t of n by 5 plus t of 3n by 5 plus n. Just try to solve this particular example and let's see who will give me the correct result. So in every example, whichever I am discussing here, you are observing one thing now. I think you are observing one thing now. Every particular example have more than one recursive term, right? Obviously, that's when you have more than one recursive term, then only you will be able to create that recursive tree, which is having some data at the left side and some data towards right side. Do it patiently. It's not that much simple. There is something which is different from the above examples that we have discussed. So don't be in a hurry to give me the answer. Take your time and let me know what is that one thing which is different here with respect to the examples that we have covered up till now. Exactly. So Grijesh is reaching to the point that when we are adding n by 5 plus 3n by 5, it is not equal to n. So here, if you will observe in this example, the cost requirement which I am talking about, at every level, it will be different if you will observe it carefully. So here you manually need to add all the levels. So basically what we are doing until now is that, let me give you one example. I think that would be better to make you guys understand. What can be the example I can give to you? For example, I am saying that I am having 10 chocolates. Okay. 10 choco bar I am having. Now, there are 5 students, 1, 2, 3, 4, and 5. There is one problem statement where so you don't know that how many total number of choco bars I have. So in one case, I am saying that for all the 5 students, I am giving 2 choco bars. So you can give me the answer. How many total number of choco bars you have? How many number of choco bars you have? How will you evaluate? 10, how will you be able to get? So some student will say that what I did is that I did 2 plus 2 plus 2 plus 2 plus 2. The answer is 10. Someone can say that I did 2 into 5. I got the answer as 10. Two approaches. Either we can add it manually, until the number of students that we have, or because I am giving equal number of chocolates to everyone. Sorry, ice cream, chocobar is an ice cream. So I am giving equal number of ice creams to everyone. So I am doing 2 into 5 as well. So in the previous examples that we have discussed, those two examples, consider that we are taking the second approach. What is happening, bro? So in the previous example, what we are discussing is that, so this is choco bars. We are moving towards the second approach, where at every level, if you remember, our cost was same. So what we did is that, how many number of levels we have, which is 5 into 2. You can also add it, but this is the simplest approach which we find out. In this example, if you will observe, take second scenario now, scenario number 2. I am saying that I am having again 5 students, but at this point of time, I am giving unequal number of choco bars to the student. For example, one student 1. For the second number student, I am giving 2. Third number student, I am giving 3. I am giving 4. I am giving suppose 6, something like that. Maybe some series is forming up. How many total number of choco bars do I have? How will you evaluate? Now, can you use the second approach in this scenario? No, you have only one method now. That is to do the manual addition of all these chocolates or choco bars and to give me the answer. That is what is happening here in this third example, which I am discussing. So here, if you will observe, we will be having a question in which at every level you will be having a different cost. So now you can't apply that second approach. And what maximum students did in the session is that they give me the correct, very frequent answer by applying the second approach, where they have just mentioned n into, they have evaluated the number of levels, which one is having a higher level, and they give me the answer. I think that's what you guys did, those who gave me the answer within seconds. But you didn't observe that at every level cost is changing. So if cost is changing, then you need to add manually all the levels until the value of k that you got. Now who will give me the correct answer? So basically, if you will observe, this n is divided into 2 parts, n by 5, and the second thing is 3n by 5. What is the cost requirement here? It is equals to n, right? Again, you will divide it again. It will be n by 5 square, and it will be 3n by 5 square. Can I say? I think it's simple to everyone until now. It will be also 3n by 5 square. It will be 3 square n by 5 square. Right, everyone? So if you will observe here, what we are doing, simply on the left side, we are taking multiplication with 1 by 5. On the right side, we are taking multiplication with 3 by 5. Perfect. I think this is same whatever we discussed until now. Now, this will be the operations of the cost required will be n by 5 here, 3n by 5 here. Total cost will be, who will tell me? Total at second level will be, cost will be not n. It will be the summation of these two, n by 5 plus 3n by 5. It is equals to 4n by 5. So if you will go at the above recursive tree, so what was happening is that when you are adding this n by 5 plus 4n by 5, we are getting the value as n. Even at the next level, when you add all these terms, you will get the value as n when you add all these terms. But in this next question, which I am discussing as of now, you will get this 4n by 5. Now here in the next level, if you will keep on dividing, and you will be able to get again the cost as n by 5 square plus 3n by 5 square plus 3n by 5 square plus 3 square n by 5 square. If you will add this, you will be able to get the total cost as 4 square divided by 5 square into n. Are you getting this answer? Try to add this. Are you getting? Now, you need to understand how many number of levels do we go. That we can evaluate very easily. I think everyone knows how we can evaluate. So left side, the series will be n by 5 to the power k, which is equals to 1. So value of k will be equals to log of n base 5. Correct? So it is log of n base 5. On the right side, it will be n by 5 by 3 to the power k, which is equals to 1. Right? So here n is equals to 5 by 3 to the power k. So k is equals to log of 5 by 3 base n. Oh, sorry. It will be log of base 5 by 3 n. Can I say? Second cost is nothing but is the summation of n by 5 plus 3n by 5. See, when you are doing a splitting of the records into two parts, the cost will be exactly the same of the number of records that you have. So when you do the same split for n by 5, the cost will be n by 5. When you do for 3n by 5, cost will be 3n by 5. So for the second level, what is the total number of cost? What is the total cost? It will be the left side plus the right side. So it will be n by 5 plus 3n by 5. So it will be equals to 4n by 5. Similarly, for the next level, if you will add, you will be able to get, it will be, just add it. Just add it, n by 5 square. So when you do the split, you will get the n by 5 square plus 3n by 5 square plus 3n by 5 square plus 9n by 5 square. Just add it. 9 plus 3, 12. 12 plus 3, 15. 15 plus 1, 16. 16n by 25. Which I can write it as 4 square n by 5 square. Can I say? Can I say? Perfect. Okay. Now, which one is bigger? Which one is bigger? Who will tell me? Can I say this is greater? Lower the base, higher the value? Okay. Now, until example number 1 and example number 2, what we usually do is that we used to apply the second approach, this one. Because at every level, our cost was same. So we just did the n into k. But at this point of time, at every level, if you will observe, your cost keeps on changing. So can I write this as 4 by 5 to the power 0 into n at the first level? Can I say this 4 by 5 to the power 1 into n at the second level? Can I say at the third level, it will be 4 by 5 to the power 2 into n? What I'm saying is that I will do the manual addition now. So it will be 4 by 5 to the power 0 into n, 4 by 5 to the power 1 into n. So 0th level, first level, second level, and I need to go until how many number of levels? How many number of levels I need to go? Who will tell me? Until k levels, right? Which k? Bigger one. What is the value of bigger one k? It is log of n base 5 by 3 into n. N will remain as it is. Now, what is this series called? Who will tell me? Take n as common. 4 by 5 to the power 0 plus 4 by 5 to the power 1 plus 4 by 5 to the power 2 until the value of 4 by 5 to the power log of n base 5 by 3. What is this series called? GP series. If you will observe, this is a GP series. Where? What is the value of R? Common ratio. How will you evaluate? Just do the division of two consecutive numbers. So the common ratio R is nothing but is equals to 4 by 5. What is the value of A? So here the value of R is less than 1. What is the value of A? It is 4 by 5 to the power 0, which is equals to 1. Now, what is the sum of a GP series when the value of R is less than 1? I think in the last session also I have discussed this point. Sum of GP series. Who will tell me the answer? When the value of R is less than 1. A into 1 minus R to the power n divided by 1 minus R. This is the formula to calculate a sum of GP series. We discussed, I think. Have we discussed GP series in the last session? No. So maybe I think I took another session. So basically, whenever we talked about GP series, there will be a common ratio. So here, if you will see what is the common ratio meaning is that it will be 4 by 5 to the power 1 divided by 4 by 5 to the power 0. Now, when the value of common ratio is less than 1, this is the sum of GP series. These things we have, we already should know because these things are already been there in 11th, 12th maths, right? So basic things, just remember these things, you will be able to get an idea. Now, what you can do is that you can try to solve this equation, and whatsoever be the value you will be able to get, that will be the answer. I think you will be able to get some constant number. So it is n, and inside that you will be able to get some constant value when you solve this GP series. So the by default your time complexity will become big O of n using a recursive tree approach. Try at your home, solve this equation, you will be able to get the answer. But the major point here you need to understand is that every particular layer or level, if the cost is different, then at that point of time, you need to manually do the addition. So don't need to cram anything, try to understand everything, then you will be able to get the answer. Is this fine? What I'm saying is that when you solve this equation by taking A as 1 minus 4 by 5 to the power, what is the value of n? Log of n base 5 by 3 divided by 1 minus 4 by 5, you will get some constant answer. So here, once you solve this at your home, you will be able to get, so n is outside. If you remember, n is outside we have, right? We took n as common. So n into some constant is something which is big O of n. There is no as such, Venkatesh material to go for AP, GP and logarithmic series. Just go and see what is the summation of AP series, what is the summation of GP series, because these things you guys already know. It's just that some revision is required. What is logarithmic series? There is no as such proper material that I have, which I can refer to you, that go to that website and you will be able to get. You can easily see at any of your website, right? And just revise these concepts. That's it. AP, GP, logarithmic, exponential you should know. And that's it. Yeah, NCERT textbook, anything. Like if you have those textbooks, you can go into that particular thing as well. Okay, so I think it's 5:10. So any doubt here until this part? Now, before going towards any of other thing, let me try to give you some problems that you can practice at your home first of all. So do one thing here. So problem number 2 is, problem number 1 I already gave in the above part. It will be T of n, which is equals to T of n by 2 plus T of n by 3 plus T of n by 5. Now here you will be having 3 terms. Until so far, whatsoever examples we have discussed, we have talked about only 2 terms, right? So this is the assignment problem. Try at your home. So here the split will happen for 3 terms like this. N it will split into 3 parts, n by 2, n by 3, n by 5. And the cost requirement will be equals to C. In the next level, it will be obviously C when you do the splitting into 3 parts further. And you will be getting total 3C here. Do this, solve this question. Apart from that, what question I gave you? Yeah, this is also the assignment problem. Practice at your home. Let me try to give you a few more problems. Okay, so one more problem which I want to give. Problem number 3. T of n which is equals to 1 when the value of n is equals to 1. And it is 8t n by 2 plus n square when the value of n is greater than 1. So solve this problem as well. So 2 problems are using substitution method and 1 problem using that recursive tree approach. Fine, everyone? Okay. Now the thing is, let me first of all save this file and share the content with you all. So this is lecture number 3. And here mainly we have discussed substitution and recursive tree approach. So let me share with you the content first of all. Check once, is this accessible to everyone? Perfect. Okay, so someone if wants to practice more problems, so you can easily find these kind of problems on the internet as well. So you can go there, you can explore more resources, you will be able to get. So these are the kind of questions which are very vastly asked in the GATE exam. So usually, GATE exam is something which is basically test your fundamental, and it's a exam which is basically for the masters. So whenever you want to pursue the masters in any of the IITs or NITs or any of the colleges specifically in India, you need to clear the GATE exam. And for IIT specifically, you need to have a very good percentile also, like 99 percentile, more than that. So you can go and check the past year GATE questions for DSA, specific to the recurrence relation or specific to the time complexity part. You will be easily able to get the questions, and you can practice that with the solutions also you will be able to get. And if you face any sort of issue in that, you can ask me before starting of the session or at the ending of the session. We can discuss those questions. But here the objective here is simple, very simple, that I want to make sure that the fundamentals whatsoever is there with respect to DSA should be pretty much clear to everyone. And after that, I will give you some practice problems, and that practice problems will just test you that is the live session is clear to you or not. Is the concept is clear to you or not? After that, the more you practice, the more you will be able to get the understanding. 10 questions, 20 questions, 30 questions, nothing is enough here. If you have the time, go explore more resources, check out more questions, and do as much as you can. But whatsoever I'm giving to you is the minimum thing, what you need to do in order to continue for the upcoming sessions. That's the important thing that you need to understand. Okay. Okay. Yeah, those questions. So what I can do here is that as of now, because it's already late, it's about 5:15, and very soon one more meeting I have to join in this platform. So tomorrow, before starting of the master's theorem, what we will do is that I will first of all discuss the last week's assignment problem. We will do the discussion of that. So I think there are 6 problems. So those who didn't did those problems till yet, take your time. You have one more day. Tomorrow, first of all, we will start with that particular part from the starting of the session. So discussion of assignment problems. Tomorrow's agenda. That one also and today's one also we will discuss. Okay. So these 3 problems which I gave, and those problems also. So those problems we will discuss. We will discuss the solution. If everyone is getting the same solution and if everyone knows how we can solve that, we will move ahead. If there is some problem where you are facing some trouble, so at that point of time, what we can do is that we can take that problem and I will discuss that problem in the class with a solution. Second thing, after discussing that thing, second important thing is that logarithmic, because many students are requesting. So logarithmic formulas that you should know, I will make sure I will give the writing part of that as well. After that, third thing which we need to discuss in tomorrow's class is the master's theorem, which is very important theorem. And this is the theorem that we will use quite frequently in our classes. So don't miss the tomorrow's session. We will discuss this theorem. This substitution and I would say recursive tree approach is taking a lot of time, and I can say it's taking a lot of mathematical towards mathematical foundation part is also there. But when we talk about this master's theorem, it is very easy. It is not taking much time, and with practice you will be able to understand that how we will be able to solve any recurrence relation within seconds with the help of this master's theorem. So this is the theorem that we will discuss. After discussing all these things, if the time permits to us, then we will start the concept of array data structure in the tomorrow's class. If time will not permit to us, then we will start from next week our actual portion of the data structures, which is array. From there, we will start our concepts related to data structure and algorithm. So after completion of this thing, we are done with the analysis module. So once we are done with the analysis module, if you remember the steps that I have showed you in my first class, the steps required to write any of the code or to solve any of the problem statement, there the last part was analysis. If you remember, the 6th point was analysis, which we will cover up by tomorrow at max. We will be able to cover up that. And after that, we will start the data structure portion, where we will talk about in depth this data structure. We will, after that, start the implementation part as well, where we will do the live code implementations of the things that we will be covering up, right? But to understand or to start these points, if suppose there is someone who missed the classes of analysis and is there in this class, I am requesting to everyone, those sessions whichever you missed up, even though we will be having only 2 classes last week and 2 classes now, please go through all those sessions. Otherwise, you will not be able to get the concepts related to for the data structures and algorithms. No, how recursion occurs, recurrence occurs, and how it will be solved, that is there inside the divide and conquer module. So that module we will start after completion of this array data structure. Okay, so we will start this after this particular module, because to understand algorithms, so this is a part in algorithms. So to understand algorithms, we should have the understanding of the data structure, right? So firstly, we will discuss the data structure, which is array. On this data structure only, we will use this divide and conquer module. And for that, you should be having a good idea about the analysis portion that we have covered up. So in this module, we will see that how basically the today part that we have discussed about recurrence relation, we will see that how recurrence relation is created. Then all your queries related to that particular part will also get clear. But once I will show you the recurrence relation, at that point of time, I will give to you as an assignment that, okay, I have told you that how this recurrence relation is created. Now you give me the answer, what is the big O time complexity? So at that point of time, you should instantly give me the answer that, okay, I applied the Master's theorem, or I applied the substitution method, and I got this big O time complexity there. Right? Will you use Python or JavaScript for code implementation? Anything I can use. I can either use the Python, or I can give you that, okay, you can go with JavaScript, or not only Python or JavaScript or any other programming language. If you want to go, you can go. It's just that for the course, we need to maintain some consistency. That's why we go for Python and JavaScript in our specific course. So anyhow, you will be able to get the resources where all the codes are there with respect to Python as well as the JavaScript. But in our classes, either we will go with the Python implementation or the JavaScript implementation, because everything is same, logic is same, pseudocode is same. Implementation wise, we will do only one thing, and other thing you can just refer the resource and you can get that. Right? Okay, so you guys just mail me if you have any doubt further, priyabhatia@ineuron.ai. But I would suggest just wait for tomorrow. Tomorrow, I'll start by taking the doubts and discussing these 3 things first. And after that, we will start the next new things. So as of now, I am ending the session. Tomorrow, let's meet at the same time, right? From 3. And then we will discuss your queries. And if still there is something urgency which you want to share, because there are so many queries which are hanging up here. So you can just mail me out, okay, in my email ID. Okay, thank you. Bye-bye, everyone. See you tomorrow.